This is an ABC podcast.
Hello and welcome to The Health Report with me, Tegan Taylor. Today, the first of two features about how animal and human tissues are being used in modern medicine. Right now, about 1,900 Australians are waiting for an organ donation. It can be a long wait, and many people may die before a suitable organ is found. But some researchers think we're at the point of growing organs in animals that could be safely transplanted into humans. This field raises ethical questions, and bioethicists would like us to think about where we stand on this type of medical development. Here's ABC Science journalist Carl Smith with the story.
Late in 2019, Myrna Taylor was preparing a family feast.
Because it was my daughter's birthday and I was cooking this special Italian dish.
Her grandson was helping to learn more about their Italian heritage.
And I was just waiting for him to come and assemble it all.
But then Myrna began to feel unwell.
I got really, really breathless, and then that's when I started to panic, and I had to get an ambulance and take me to the hospital.
Myrna had a history of heart problems, and she'd been trying to manage them. But after this day, in October 2019, she really began to struggle.
I couldn't walk 10 paces without stopping and gasping for breath.
Myrna's now 85. She lives in a retirement village in Mullaney in the hinterland of the Sunshine Coast. And she's alive today because she's had part of an animal transplanted into her chest. After months of trying to manage her breathlessness, Myrna met with specialists at the Wesley Hospital in Brisbane, including cardiologist Dr. Anthony Camulia.
So she had fluid building up throughout her whole body. Her blood pressure was getting lower and lower, and her heart was failing.
Two of her heart valves were severely leaking, making it harder for her heart to push blood around her body.
I distinctly remember going into her room late in the afternoon. Various family members were coming in to see her because of how unwell she was.
At this stage, I thought, well, I didn't think there was much they could do.
The options for her, there were really three options. One option was palliative care. Another option, which really wasn't realistic in her setting, was open heart surgery. The third option, which has become a very realistic prospect in the last few years, is to take a catheter, which is just a hollow tube up through the artery in the leg around to the heart, and attached to the end of that catheter is a new heart valve made out of a combination of cow and pig. Put that new valve inside the old one that's failing, allow it to expand, and it takes over the function of the old valve.
This procedure is known as a TAVI, or transcatheter aortic valve implantation. The replacement heart valve is a cylindrical metal frame with pig tissue around the outside, plus a flap of cow tissue inside that acts as a valve. You might have heard about these, or you might even have one. Dr. Camulia says each year, around 3,000 to 4,000 Australians will get a heart valve made partly from animal pericardium.
Peri means next to, cardium, heart. And it's a wrapping around the heart that's made out of tough, fibrous material that's rich in collagen.
This animal tissue is treated to kill most of the living cells, but it's still a procedure that involves transplanting animal tissue into humans.
And we use the term xenograft, xeno meaning completely foreign, and graft insertion. And that really means we're putting animal into a human.
After Myrna's xenograft heart valve had sprung open, she began swiftly recovering.
If someone like Myrna had turned up like that 10 years ago, when we didn't have access to the transcatheter valve option, would probably have spoken to Myrna and her family about saying their goodbyes.
The idea of having animal tissue transplanted into a human body can feel unsettling or unnatural. But Myrna says she hasn't thought twice about her animal implant, except when her kids made a few jokes at her expense.
My sons used to grunt when they walk in the room. Grunt like a pig, you know. And I'm a bit pig-headed. Yeah, no, Doesn't worry me. I don't even think about it, actually.
It does surprise me a little bit, actually. Most people don't seem to care. It doesn't seem to worry them. And we've done several hundred of these procedures, including patients from very diverse religious and ethnic cultures. I've not had that come up as an obstacle.
But would patients be as comfortable being transplanted with a living, beating animal organ? A whole pig's heart, for example. Anthony Camuglia.
I think that would represent a very different prospect. Essentially what we do now is it's a highly sanitised looking piece of equipment, right? Whereas I suspect that would challenge people more. At the same time though, people often surprise themselves of what they'll accept when they're in a situation of increasing desperation.
But it might be time for us to examine exactly how we feel about having a living animal transplant. Because around the world, research teams have been embarking on new clinical trials of xenotransplantation. In other words, transplanting living animal tissue into humans. And you might one day face the decision of either transplanted animal tissue or just a few days left to live. Xenotransplantation is clearly a field that some will find challenging. But turning to animals for organs and tissues has been born out of grim necessity.
We've got hundreds of thousands of people waiting around the world on waiting lists. In Australia, several thousand people waiting for these transplants, up to 10 years for some of these patients, and they won't end up, some of them, making it to transplant.
Wayne Hawthorne is the president of the International Xenotransplantation Association, and he's a researcher and professor of transplantation at Westmead Hospital and Sydney University. He says there's a long history of looking to animals to fill this ongoing organ shortage.
And obviously the big one that people heard about a number of decades ago was baby Faye getting a transplant, a heart transplant.
From the moment she left the operating room, controversy surrounded baby
It is not a cure, it is not a therapy, it is experimentation.
Stephanie Faye Beauclair was born in the US in 1984 with a severe heart condition. Her medical team didn't have enough time to find a suitable human heart, so without a better alternative, they tried an animal heart.
It was from a baboon. Even though we are closely related phylogenetically, it wasn't similar enough and they had a massive rejection episode.
In America, the baby who was given the heart of a baboon is having problems.
Faye, who's now about a month old, is showing the first signs of rejecting.
For 20 days, a baboon heart beat in baby Faye's chest. It was a medical first, some said a medical miracle.
Baby Faye died from a rejection which was much more profound than the usual kind.
This wasn't the first time surgeons had turned to animal organs in desperation. And the problem was always the same: rejection. Our bodies are designed to detect anything foreign and get rid of it to stop infections.
The body looks at these cells that are coming in or tissues being transplanted into a patient, and what happens is they recognise them as foreign.
But Wayne Hawthorne says we're on the cusp of successfully genetically modifying animals so that human bodies won't reject their cells, tissues, or organs. This work has been underway for the past few decades, and much of it is focused on pigs. Their organs are roughly the same size as ours, and they grow quickly. Plus, we already use dead, unmodified pig tissue for xenografts, like with Myrna's heart valve. The first step has been to understand what makes pig cells stand out to our natural defences.
The big defensive mechanism that we have a number of preformed antibodies. One of those is called alpha-gal transferase, and that's particularly targeting pig. It's there to protect you from those foreign invaders, and the body immediately sees pig cells or pig tissue as foreign, and it sets up what's called hyperacute rejection. Now, like NASA, your body has a number of redundancies. There's a fail-safe. If that doesn't stop it, it's got a secondary set and a tertiary set and a quaternary set.
But researchers have been able to understand those defences and genetically modify lines of pigs so that their cells and tissues slip past each layer of defence unnoticed. They're often called humanised pigs because their cells are designed to appear more human.
We're producing an animal that is still very much a pig, but it produces a protein, basically a sugar on its cell surface, to express a couple of molecules that are human.
The wide use of fast new gene editing tools has sped up this process. And a raft of recent studies transplanting organs from genetically modified pigs into other animals, including primates, has shown that they won't be rejected and that they work.
We have come forward leaps and bounds. We've gone further than 500 days post-transplant in these animal models to show we've got functional cardiac survival. The same with kidney and liver. We're now out past a year post-transplant.
Wayne Hawthorne's own work has focused on transplanting a cluster of insulin-producing islet cells from the pancreas of one animal into other animals with type 1 diabetes, so they can make insulin again. This field has proven to be one of the most promising for xenotransplantation.
We've gone further than 2 years post-transplant in preclinical trials where we set up an animal model of diabetes by rendering the recipient animal diabetic, and then we've implanted islet cells and had successful reversal of diabetes.
Xenotransplantation between animal species has proved so effective that some groups have even tested it in humans. The first tentative steps were taken in the 1990s. After some early failures with whole organs, many teams switched to small sections of animal cells or tissues.
So in 1995, there was a registry established, and there's been more than 29 different types of transplants, such as islet cells for treatments for diabetes, kidney cells, chromaffin cells, embryonic stem cells, fetal and adult cells from various organs, spleens and kidneys. And over the last 10 years, from 2010 to 2020, there's been 4 applications for human xenotransplantation from around the world.
The results of these small clinical trials have been patchy. One recent Chinese study showed that pig islet cells were safely transplanted into 21 people with diabetes and weren't rejected. But they didn't really help, resulting in only minor improvements to insulin production in some patients over the first 3 months, with no long-term benefit. Some of the best tolerated xenotransplants in humans so far have been small clusters of cells.
Certainly there's been a number of cell transplants for islet cells and choroid plexus cell transplants even in New Zealand for treatments for Parkinson's, where they've implanted these choroid plexus cells into the brain of the patients.
Even though these xenotransplants also proved to be safe, the trials showed these cells didn't improve the symptoms of Parkinson's patients. Even though these are small steps, Wayne Hawthorne says the field has been spurred on by results like these, showing humans aren't rejecting animal tissues. And he's hopeful that a newer raft of trials will show xenotransplantation can consistently help patients too.
The trial that's just about to start and has been given full approval internationally and by the Korean government is a clinical trial to test islet cells from pigs into humans.
But are we ready for a world where animals make spare organs for us?
A chimera is a person or an animal that has more than one defined cell in it. So it's cells from 2 distinct individuals or more than 2.
In modern science, the fusion of multiple living creatures is commonly called a chimera. But that term can conjure grotesque images. The chimera of ancient Greek legend was a lion with a goat's head and a snake sprouting from its tail. The idea that we might create that kind of creature around a human frame has likely fueled public concerns around xenotransplantation.
I think the idea of chimeras historically has been that idea of something fantastical.
Dominique Martin is an associate professor in bioethics and professionalism at Deakin University.
Whether it's seen as a monstrous beast or some kind of magical being with supernatural powers, even though I think there's the same element of fear, whether it's a potential force for good or evil, it might be something that people would be frightened of because I think it represents something that is very different from our own experience, something that is kind of archetypally unnatural.
Some might also be concerned about whether having animal parts would make them less human. But Dominique Martin says it's time for individuals to reflect on these concerns and how valid they are, because animal-grown organs are coming.
Absolutely. The latest research and just clinicians, researchers talking about this topic really seems to indicate that we are on the verge of seeing some exciting clinical translations into human beings. And we need to prepare for that. We need to think through some of the ethical implications and think about the conditions that we might set.
So what are people's major concerns when it comes to xenotransplantation?
They can include concerns that perhaps some attributes of the donor, so some characteristics or even the personality of the donor might impact them if they receive a transplant. Some studies have shown that a few people express that as a potential worry.
People are concerned that, we could end up with all sorts of cross-species changes. Now, that's not possible.
More practically, I think people are concerned about the clinical or physical risks of receiving an organ from a non-human donor. And that could be uncertainty about what the quality of those organs would be, whether they'd work as well as an organ from a human donor, and perhaps particularly in the current climate, concerns about the risk of infections that might be transmitted from animals to humans.
This has been a long-standing issue.
Pigs have viruses embedded in their genes, so-called porcine endogenous retroviruses, or PERVs.
I think the risks here, one can argue, are theoretical, but there's enough background information to show that this is just not a pie-in-the-sky worry.
The discovery of these pig retroviruses was made in London in 1997 by virologist Dr. Robin Weiss. Its publication in the journal Nature temporarily halted xeno research around the world.
Retroviruses discovered in pig DNA led to a moratorium on xenotransplantation in Australia in the mid-2000s. In 2009, the National Health and Medical Research Council lifted that moratorium because the risk of transmitting animal viruses via xenotransplantation is very low. The NHMRC said at the time the risks, if appropriately regulated, are minimal and acceptable given the potential benefits. And Wayne Hawthorne says a lot more work has gone into tackling PERVs since then.
We've bred pigs that aren't actually PERV expressing. The other thing that we've done now with CRISPR-Cas9, the US study was published a couple of years ago now, where they've actually knocked out all the porcine endogenous retroviruses from a donor pig.
A lot of those early concerns, in particular about the retroviruses, have now been addressed. But there will always, of course, be concerns about the potential for transmission of infections or diseases.
Especially in the wake of SARS-CoV-2. To help stop other microorganisms finding their way into humans, the modified pigs are kept in tightly controlled facilities. Some animal rights groups have expressed concerns about animals spending their whole lives in those conditions, to be killed whenever we need them.
And of course, many people will say, well, we do that every day. We kill animals for food or for other reasons. And so, this would be particularly justified to do that if killing the animal would mean we were directly saving the life of a human being.
There are also some possible limitations to xenotransplantation that we won't know about until it's more widely tested. For example, pigs tend to live for about 15 years. But will their organs last longer than that in a human? Despite all these concerns, Dominique Martin points out that several recent surveys show the public is broadly supportive of xenotransplantation.
So there hasn't been any recent research in Australia, but internationally there have been a number of surveys conducted and interview studies conducted, particularly in the United States, but also in Europe and in parts of Asia. In terms of what the general public think, it's quite interesting. There seems to be majority support. Probably, on average, it seems to be about 2/3 of respondents in these studies tend to be in favour of xenotransplantation, given that significant value of saving a human life.
Ultimately, Dominique Martin believes some people may still object to xenotransplantation.
But fundamentally, that's probably going to come down to people's differences of opinions about when, if ever, it is justifiable to kill a non-human animal.
Now, alongside this work humanising animal organs, there's another related field with the same ambitious goal of growing organs for humans in animals. As we've heard, a patient who receives an animal organ would officially be classed as a chimera. But some researchers have begun trying to create true chimeras by fusing human stem cells with animal embryos.
So there has been tremendous progress, particularly in very recent years.
Fung is a professor in the Department of Physiology and Biophysics at the State University of New York at Buffalo. His lab is one of a handful around the world that's been able to create true embryonic chimeras.
There's a lot of research on interspecies chimera with the goal of making perhaps human organs in different species. People tried mouse, pigs, sheep. So the field is very active.
In fact, in early 2021, a human-monkey chimera embryo was created by a team including one of the pioneers of this field, Juan Carlos Belmonte, at the Salk Institute in the US. To create embryonic chimeras, Fung uses human-induced pluripotent stem cells.
That you can generate from anyone at any time, from almost any type of cell. The easiest would be for us to collect a sample of urine. When we urinate, we flush out some cells. These cells can be cultured and it can be converted into these induced pluripotent stem cells.
These cells are essentially reprogrammed, reverting to an earlier embryonic state, and can then be injected into a developing animal embryo just a few days after it's fertilized.
They can actually co-develop as if they're their own cells.
Professor Fung's team has been using this process to make human mouse chimeras.
You just inject about 5 to 7 cells into a mouse embryo, and then if the experiment is successful, the mouse embryo will have human cells.
So far, human-animal chimera embryos only have a smattering of human cells. But the goal is to control exactly where they develop in animals to produce human organs in animal bodies.
So I would say it's pretty far off at this point. So what we imagine that will work in the best case scenario, instead of using a mouse, you will use a larger animal, for example, a pig. Let's say if you want to make a human heart, right? So what you need to do is then you want to make a special pig embryo. This pig embryo will not be able to produce the pig heart. Then you put in the human cells. The human cells are totally healthy, right? So it will intermingle with the defective pig embryo. So then, in theory, you can actually make a human heart in a pig.
There are plenty of hurdles to jump to reach that goal. One is that the chimeras created so far have a very small proportion of human cells, often around just 0.1%. Fung's team recently celebrated creating a human-mouse chimera with a higher proportion, but this is still an area that will need more work.
We know that we have roughly about 4% that are human. And not only that, these human cells are converted into many different types of mature human cells.
But as we increase the number of human cells scattered randomly across a mouse embryo, would these chimeras still be considered animals? Dominique Martin.
I don't think there's any consensus or anything perhaps like consensus even with regards to the ethical status of chimeras, but there probably is some consensus in terms of the types of chimeras we worry more about, ethically speaking. So if a chimera is created that has characteristics that we think of as being typically human, in particular the chimera's brain, if we're creating or changing the brain of this animal in ways that would make it more like a human brain or have the human capacity for cognitive thought, that's something that ethicists in particular are very worried about. And if we were to create animals that were like us in that sense of having those human brain capacities or functions, then most people would, I think, tend to agree that we ought to treat them like we treat our fellow human beings.
Currently, embryonic chimeras are only allowed to develop for a set amount of time, to try to stop them developing anything like human consciousness. And research teams are developing finer tools to restrict where human cells can grow in a chimera's body. Fung believes these safeguards are strong enough for now.
Our sense of self-awareness, our sense of being a human being, is really a function of the brain. Let's say if you generate a kidney, it has nothing to do with the brain. So whether we should treat that chimera as a human, I would say that we have more reason to believe that it is an animal with a human organ.
But different countries are allowing this research to move ahead at different speeds. The US isn't allowing public federal funding to support human-animal chimeras that develop beyond 14 days after fertilisation. But Japan has swung the other way, recently lifting restrictions and allowing human-animal embryos to be transplanted into an animal's uterus and brought to term. Megan Munsey, Professor of Ethics, Education and Policy in Stem Cell Science at the University of Melbourne, says it's time to take a closer look at Australia's regulations.
When you look at the legislation around the use of human embryos in research, and we've had that legislation in place since 2002, chimeras are defined and it's explicitly prohibited research involving chimeric embryos, but the embryos are defined as adding animal cells to a human embryo and are actually silent on the reverse. And I think that issue has caused some confusion in the community, so perhaps it is time for a conversation around whether we have sufficient regulation or at least guidance here in Australia.
She also points out that there's a dearth of research on the Australian public's views towards creating true human-animal chimeras. So she says chimera research teams should move slowly. But for Megan Munsey, there's been an elephant in the room throughout this entire discussion.
So whilst there are some really interesting areas of research that might provide a new solution to this problem, I really think we have to look at how we're recruiting donors and what the challenges are, why Australians aren't donating organs in the first place.
But given traditional human organ donation rates remain stubbornly low, she wants the public to begin thinking seriously about where they stand on xenotransplantation, and not just in an abstract way.
I think when presented with whether you would rather potentially have your health compromised or take up an opportunity to have perhaps animal cells, you might well change your mind. So I think it's often in context. How people view this issue may change throughout the course of their life, throughout the course of an illness.
When Myrna Taylor was given 4 days to live, she didn't hesitate to pick a life-saving animal heart valve.
I'm living quite comfortably on my own, doing all my own housework and everything. I go for a little walk every afternoon around the village.
But would she have felt the same if it was living animal tissue?
If you were as sick as I was, I suppose, you couldn't care less what went into you, could you?
And I hope you can join us next week for the second of Carl Smith's features, how the use of animals could improve treatment for cancer patients receiving chemotherapy. This has been The Health Report. Catch you next week.
You've been listening to an ABC podcast. Discover more great ABC podcasts, live radio and exclusives on the ABC Listen app.